of you in this new video. In this video I am going to explain you the procedure to draw the projections of a line if it is inclined to both the reference plane, means if a line is inclined to horizontal plane as well as to the vertical plane. So we will see the procedure for that, and to understand the procedure in a better way we will take the reference of a numerical statement, and with the help of that we will see the step-by-step procedure to draw the projections for that. And after drawing the projections we will see the procedure how to locate the traces, means horizontal trace and vertical trace. So let's start. The first step, we will go through the numerical statement. In numerical statement you can observe a straight line PQ has its end point P 20 mm above the HP and 30 mm in front of VP, and end Q is 80 mm above the HP and 70 mm in front of VP. If the end projectors are 60 mm apart, draw the projections of the line, determine its true length, true inclinations with the reference plane. Okay, the first step will be read the numerical statement carefully and write down the given data from the numerical statement so that it will be easy to us to represent in a proper way. So after reading the numerical statement you can write down the given data in the same format. I will recommend to write down the given data for all the numerical in the same format. So it will be the shortcut way, shortcut representation of the numerical statement. Okay, the given data will be line PQ is given. In that they have given the position of point P in terms of HPVP. So we can write down the point P is given 20 mm above the HP and 30 mm in front of VP. Then they have given the position of end point Q also. So end point Q is 80 mm above HP and 70 mm in front of VP. After that they have given the 60 mm distance. That 60 mm distance is regarding end projectors, projector of P and projector of Q. These two projectors will be vertical, and between them the horizontal distance is given. For that distance it is called as end projector distance. So we will write down end projector distance is 60 mm is given. Then they have mentioned draw the projections. Okay, we have to draw the projections and we have to locate the traces, and after that we have to represent or determine the true length and true inclinations with the reference plane. Now the true length is nothing but the actual length of the line, and the true inclinations are nothing but with reference plane are nothing but alpha, theta and phi. So we have to identify or we have to determine the true length, theta and phi. So in the same format you have to write down the given data for all the numericals which are related to the projections of lines. Okay, and after observing the given data or after reading the numerical statement, first of all we have to identify the locations of the both the end points of the line, whether they are present in the same quadrant or they are present in the different quadrant. Suppose if you are going to observe the given data of this numerical, you can find out the point P is above the HP and in front of VP, point Q is above the HP and in front of VP, means both the points are present in the first quadrant. And as per the first quadrant, all of you are aware about that, the front view will be get represented above the reference line and top view will be get represent below the reference line. So you have to remember that condition, where will be the position of front view and where will be the position of top view. Okay, now after writing the given data, now the step by step procedure we will observe how to represent the projections. Okay, the projections are nothing but we have to represent the final front view and top view of the given line. So the first step will be, always we have to draw the reference line and name that reference line as XY. So the first step is draw the horizontal line and name that line as a X and Y. Capital nomenclature should be there. Okay, then the second step will be locate the projections of point P. Okay, because the point P locations are given above the HP and in front of VP. That projections we have to represent as a P dash 20 mm above HP, that is a front view, and P 30 mm in front of VP, that is a top view, with dash front view location and without dash top view locations. That you have to remember. Always the front view will be get represented with dash nomenclature and top view will be without dash but with small alphabet. So the next step, we have to locate the 20 mm distance above the HP, means above the XY line, and we have to draw the projection line which is exactly parallel to the XY, and locate any one point on that line as per the space availability and name that point as a P dash. Then the same P point is also represented in front of VP by 30 mm distance. So we have to represent 30 mm distance below the XY line, and again we have to draw one more projection line which is exactly parallel to the XY. Okay, and remember one thing, all the lines after completing our diagram, we have to observe that all the horizontal lines should be parallel to each other, and all the vertical lines should be parallel to each other and perpendicular to reference line. Okay, now after representing the dimensions and representing the only front view as a P dash, we have to locate the top view for the point P. For that we have to draw the vertical projector from P dash point, and where it will intersect with the 30 mm dimension line, that will be the exact location of the top view of the point P, that is small p. Okay, now the next step, locate the end projectors locate the projections of the point Q, that is distance 80 mm above the HP and 70 mm in front of VP. They have given 80 mm point P locations also has been given, so that we generally one first point will be get represented towards left, and the second point generally it will be get represented towards right. So we will represent the distance 80 mm and 70 mm which is related to the point Q towards right side of this diagram in this way. 80 mm above the HP means above the XY line, and we have to draw a locus line at that particular distance which is also exactly parallel to the reference line, and name that locus line. That locus line is locus of Q dash. Just look at the way of representation of that line. It is not a continuous line, it is a chain line. Okay, similarly second dimension, 70 mm in front of VP, locate the dimensions and draw the locus line which is exactly parallel to XY, and name that line as a locus of Q. Okay, upper line is locus of Q dash because on that upper side line, that locus line, on that locus line the front view of the end point, second end point of front view will be get represented, that is Q dash. Okay, that's why we have to represent as a locus of Q dash. Then after this, the fourth step will be represent the two locus of two locus line. It is already done. Then the next step, locate the end projector distance. Okay, one more information which is given to us, that is end projector distance 60 mm from the, just read carefully, locate the end projector distance 60 mm from the projector of first point P, means this P dash to P, this is the first projector line, and from this we have to locate the 60 mm distance horizontally, and we have to draw the one second projector line which is exactly perpendicular to the XY. So locate the 60 mm distance. Generally we have to represent the distance somewhat away because it should not intersect with any other line. So from the first projector, measure the distance 60 mm, locate the distance, and next step, name the point Q dash and Q at the intersection of the second projector line with locus lines. Means after representing the 60 mm distance, we have to draw the exact vertical projector line, and where it will intersect with the locus of Q and locus of Q dash, at that place we have to name that point Q dash and Q. Likewise, we have to draw the vertical projector line at a distance of 60 mm from the first, and where it will intersect with the locus lines, name that point as a Q dash and Q. That is the sixth step. Next step, join the point P dash and Q dash as a front view and PQ as a top view. Means after joining the P dash and Q dash, that will be front view line, final front view line, and P to Q, that will be the final top view line. Means just we have to join this with the help of straight line. These two lines are the final views. Okay, front view and top view. Then the next step, draw a arc. Now after representing the final front to top view, our intention is, our aim is to find out the true length. Okay, so for finding the true length, we have to do the reverse procedure. Generally in conventional procedure, the true length is given to us, and by taking the true length we are going to represent the front view top view. But here already the front view top view locations are given to us, and by using the reference of that front view top view locations, we have to identify or determine the true length of the line. So for that the reverse procedure is there. Draw a arc of radius p dash to q dash and locate the point q2. Means we have to draw the arc by considering p dash to q dash as a radius, p dash as a center, and we have to draw the arc in this way. Just you can observe, we have to draw up to the horizontal line which is passing from the p dash and name that point as a q2 dash. Okay, then as per the procedure number 8, now the next procedure, from q2 dash point draw a vertical projection line up to the locus of q and locate the point q2. Means from q2 dash point we have to draw a vertical line up to the locus of q and name that point as a q2. Just you can observe here, we have to draw the exact vertical line where it will intersect with the locus of q, name that point as a q2. Okay, then the next step, join the points p and q2. P point and q2 we have to join and it will be a true length in the top view. Okay, join the point p to q2 and that will be the true length in the top view. Next step, draw a arc of radius pq and locate the point q1. Means we have to consider p to q, the top view length distance as a radius, p as a center, and we have to draw the reverse arc and we have to represent the point q1. Means in this way you can observe, p to q as a radius, p as a center, draw arc and name that point as a q1. Then the next step, from point q1 draw a vertical projection line up to locus of q dash. From this point q1 we have to draw a vertical locus line up to the locus of q dash and locate that point q1 dash. Means we have to draw exact vertical line where it will intersect with the locus of q dash, name that point as a q1 dash. Okay, then the next step, join the point p dash and q1 dash. It will be the true length in the front view. Means after joining the point p dash and q1 dash above the reference line, that will be the true length in the front view. Okay, next step, measure the length of p dash to q1 dash, that is the true length, or p to q2, that is also the true length, and the true length is always same in front view and top view, and that is our first determination. We have to identify the how much true length is there. Okay, and the angle theta and phi will be, means we have to measure the angle of true length with horizontal line in the front view and in the top view and note the values. Means that will be the angle theta and phi. When we are going to represent, means we have to identify the angle of true length with horizontal, that will be the angle theta, and angle of true length in the top view with horizontal, that will be the angle phi. Means we have to just measure with the help of angle measuring device and what is the exact value of that theta degree inclination and phi degree inclination. That is our main aim to find out the true length and find out the inclination of that true length with the horizontal line. But one more point is remaining. After representing the projections, we have to locate the traces also. The traces are nothing but the intersection of the line with either HP or VP point. So the procedure for locating STVT, just remember, if the line is inclined to both the reference plane, in that case both the points, horizontal trace and vertical trace, will be present and we have to represent both the points in the same diagram. And the procedure for that, the final front view, that we have to identify where is the exact location of final front view, that is P dash to Q dash. Extend the final front view up to the XY line and where the intersection of that extension line with a reference line, name that point as a H. Similarly, extend the final top view, extend the top view up to the reference line where it will intersect with the reference line, name that point as a small v and small h. Then from the point H we have to draw the vertical projector either towards upward side or towards lower side. That will be depends on the position of extension of the top view. If the top view extension line is present below the H point, then in that case we have to draw a vertical projector in a downward direction. If in some case this extension line of the top view is present above the H point, then in that case we have to draw the vertical projector towards upward side. Now here you can observe the extension of the top view is present below the H point, so we have to draw the vertical projector in a downward direction, and where the intersection of these two lines will be there, that point we have to represent as a horizontal trace HT. Okay, just remember H point and HT point will lies on the same vertical projector. Similarly, V point and VT point is also lies on the same vertical projector. So the procedure for locating the VT, just look at the extension of front view in comparison with the point V. If it is present on the below side, then we have to draw the vertical projector towards downward side. If the front view extension is present above the V point, in that case we have to draw the vertical projector towards upward side. But now here you can observe the front view extension line is present below the V point. So again we have to draw the vertical projector in the downward direction, and where it will intersect with the front view extension line, name that or locate that point and name that point as a VT. So that is the complete procedure for this numerical to represent the projections, identify the true length, measure the or identify the angle theta and phi, and also location of the traces. I hope all of you understood this. So thank you very much for observing and listening carefully. Thank you so much.